Today we're working on the last lesson from Chapter 1, and this is on absolute value equations. When we look at an absolute value equation, notice when we have the absolute value of x that's equal to any number, what that means is that x could be the positive value or it could be the negative value. We want to think about absolute value as being distance from 0, and so, for instance, if the absolute value of something is 5, that means the two possible answers for that would be 5 and negative 5, because each of those are 5 units from 0. One is 5 units to the right, and one is 5 units to the left. So that's going to be a key thing, as we want to think of this as distance from 0 when we think about absolute value, and that will help us just conceptually with this idea. So let's take a look at example 1. We want to solve the absolute value of 3x plus 2 equals 7. So as we look at this, remember that in here, think about what's going to have an absolute value of 7, or what has a distance of 7 units away from 0. The two options there are that 3x plus 2 could equal 7, or 3x plus 2 could equal negative 7. And so we solve this. We subtract 2, and we get 3x equals 5. And when we divide by 3, we get x equals 5/3. When we solve the other one, we subtract 2, and we get 3x equals negative 9. We divide by 3, and we get x equals negative 3. So this is going to boil down to really having two different answers, but you always are going to have that idea of a positive and a negative. So looking at this one, before we can think about that positive and negative, we do have to get this absolute value part by itself. So first we're going to add 7 to both sides, and we have 4 times the absolute value of 2x minus 3 equals 36. One thing I want to point out is you do not want to try and distribute through the absolute values. You can't do that, so we're just going to, this is 4 times the absolute value symbol, we're going to divide both sides by 4. So 2x minus 3, the absolute value of that is going to equal 9. So this is the point where we think of what two values could 2x minus 3 equal. And we know that 2x minus 3 could be 9, or 2x minus 3 could be the opposite of 9, negative 9. So again, we solve. We add 3, so 2x equals 12, divide by 2, and x equals 6. And then the other one, we add 3, so 2x equals negative 6. We divide by 2, and we get x equals negative 3. So again, two different values there with absolute value problems. When we talk about absolute value inequalities, there's some properties that we can learn, but again, I'm going to come back to that idea of distance from 0. One of them is if the absolute value of x is less than c, that means you've got this positive c and this negative c, and x is going to be between those two. Again, think of it as its distance is, the distance from 0 is less than c. Well, that means it's closer to 0 than c is, or than c units, and so that gives you that sort of an inequality. When we have less than or equal, it's less than or equal to, it's exactly the same thing, only the symbols change to or equal to symbols. When we have the absolute value is greater than c, and again, the distance from 0 is more than c. That means it's farther away than c, and so that's giving us that x is either less than negative c, further to the left, or x is greater than positive c, further to the right. So that means you're dealing with things that are farther away from 0. And again, if we have greater than or equal to, that just changes those symbols on each one of those to be greater than or equal to, and then less than or equal to. So again, we think distance from 0. A less than or a less than or equal to is going to mean that it's closer to 0, so we're dealing with the middle of our number line, whereas greater than or equal to is going to mean farther from 0, and that's dealing with the outsides of our number line. So as we look at this one, we've got the absolute value of x minus 2 over 3 is less than 2. Again, less than means we're closer. I should circle that so it doesn't look like less than or equal to. It means we're closer to 0 than 2. So if we think about our number line, here's 0, 2 units to the right, 2 units to the left. X minus 2 over 3 is going to be in this middle area. So that's how we set it up. Negative 2 is less than x minus 2 over 3, which is less than positive 2. At this point, we just solve the compound inequality. To get rid of the 3, we're going to multiply everything by 3. So this cancels, and we get negative 6 is less than x minus 2, which is less than positive 6. Then we're going to add 2 to each side, or each part. So that gives us negative 4 is less than x, which is less than 8. So that's the inequality written out as an inequality. If we wanted to graph this, we've got negative 4 over here on the left, we've got 8 over here on the right. They're both open circles because it's not an or equal to problem, and it's this stuff in between there. Okay, so that's an example of an inequality. Looking at this one, again, we do have to get the absolute value part by itself. So first we're going to subtract 8. And we have negative absolute value of 2x minus 1 is greater than or equal to negative 2. Now this is the part we have to be careful. We're going to divide by negative 1. So 2x minus 1, the absolute value of that, and we've got a 2. But remember, when we divide by a negative, when there's an inequality, we have to change that inequality so it becomes less than or equal to. So again, to kind of draw a quick sketch to give us an idea, happens to be the same numbers. You've got 2 and negative 2, that's 2 units in each direction, and 2x minus 1 is in the middle. So negative 2 is less than or equal to 2x minus 1, which is less than or equal to positive 2. We add 1 to both sides, and we get negative 1 is less than or equal to 2x, less than or equal to 3, and then we divide by 2, and we have negative 1/2 is less than or equal to x, which is less than or equal to 3/2. And again, if you're asked to graph that, negative 1/2 goes here, 3/2 goes here. These are now filled in circles, and we're talking about the space in between there. Okay? So there's another example for you. For example C, again, we've got to get the absolute value by itself. So first we're going to get rid of that 4. We divide by 4 on both sides. 3x minus 5 is now greater than 3. So again, to draw a sketch, 3 units away, 3 units to the right is 3, 3 units to the left is negative 3, and this time greater than. The distance is further from 0, so 3x minus 5 could be over here, or 3x minus 5 could be over here to the left of negative 3. So we write that down. 3x minus 5 is less than negative 3, or 3x minus 5 is greater than positive 3. So to solve this, we add 5. So 3x is less than 2, divide by 3, and we get x is less than 2/3. Or add 5 again. So 3x is greater than 8. Divide by 3. X is greater than 8/3. So there's our inequality. And then again, to graph that, we've got 8/3 and 2/3. These are both open circles. And notice less than 2. Wait, this says greater than. That should not say greater than or equal to. Cross that one off. Just less than 2/3. So x is less than 2/3, open circle. X is greater than 8/3, open circle there as well. That's it for today, the absolute value stuff. Hopefully that makes sense. Section 1-7, pages 137 and 138, you can check those out. Again, you'll have time tomorrow to work on this in class, so take a shot at some of these and see how you can do on your own first.